a pure imaginary number, I in exponent 2n in exponent I in exponent 2n. So let me rewrite this number, this pure imaginary number. So I in exponent 2n in exponent I in exponent 2n. Let n is natural number. So it's 1, 2, 3, and it goes up to m. So it means this is a finite natural number. So n is element of a natural number. And now let's take when n is an even number. When it's even. Okay, so if n is even, so n is going to be equal with a 2n. And now I'm taking just one part, I in a 2n. So I in exponent 2n is equal with the I times 2m. And this, if I'm distributing here, another exponent is going to be I in exponent 4m. But I in exponent 4m is divisible by 4. So it means I is, because it's divisible by 4, I in exponent 4m is equal with 1. As we know, I is a square root of minus 1. I square is equal with minus 1. I cubic is equal with minus I, and I in a fourth is equal with 1. So this pattern is going to repeat as we are increasing the power here. If we are incrementing by 1, or in other words, if we are increasing with respect to natural numbers. And in every fourth number is going to repeat 1. So it means that because it's divisible by 4, I in the 4m is equal with 1. So we already found out, so I in exponent 2n is equal with 1. But on the other hand, if we are looking here, for example, I in exponent 2n in exponent I in exponent 2n is as follows. So I in exponent 2n, we can write in this form, but I in exponent 2n here we can write is equal with 1. And here is a I, but 2n in exponent 1 is just 2n. And as we found out, I in exponent 2n is equal with 1. So this is equal with 1. So as it turns out, so I in exponent 2n in exponent I 2n is equal with 1 when is even. So we can write this one, we can frame, so whenever we need we have here. So it means for n even. And now we are going to look when n is odd. Let's say n is an odd number, odd natural number. And if n is odd, then n is going to be equal with 2n plus 1. And we are taking just this upper part, I in a 2n, either one we can take, lower or upper part, because it's the same. So let me take here I in exponent 2n. And instead of the n, I'm going to substitute 2m. So here is a 2 times 2m plus 1. Okay, so this is I. And now we are distributing. So I is going to be 2 times 2 is 4m plus 2 times 1 is 2. And if we are decomposing this pure imaginary number, it takes the following form. I 4m times I in exponent square. Okay, but I in 4m, we already proved here a little bit, we already proved here I in 4m is equal with 1. We already showed here. So is equal with 1. And I squared is a minus 1. And 1 times minus 1 is equal with minus 1. So I in 2n is equal with minus 1. So that's what we have here. Okay, so we have this here. So now let's take this number here, I in 2n, I in 2n. And instead of I 2n here, so let me write the base, I 2n. And instead of the I in 2n, I'm plugging minus 1, because that's what it says here. And this one here, 2 n in exponent minus 1, we can write in this form as 1 over 2n. I can make the positive exponent. Okay, is 1 over 2n. And this one here we can write as 2n root of I. So in other words, so let me write this as a final. I in a 2n, I in exponent 2n is equal with a square with a 2nth root of I. Okay, when we have a odd. So those are the two results. This is when n is odd. And when is even, we have I in exponent 2n, I 2n is equal with 1. So those two scenarios can happen in this pure imaginary number. When we evaluate, it has to value 1 and 2nth root of I.